Hi, everyone, and welcome back for another episode of Dev in the Details. Today, I'm joined with a special guest, Girish Gupta, an AI safety researcher with an unconventional background. Girish started off with a theoretical physics background at Cambridge, and then spent nearly a decade as a crisis and war reporter for Reuters and TIME in active conflict zones like Venezuela, Iraq, and Afghanistan. He then came back to technology as an engineering leader and CTO in the Silicon Valley, and today he works as an AI safety researcher at Berkeley. Given what's been in the news from both OpenAI, Anthropic, and the open weights debate, I think this is the perfect time to have you on the podcast. So, Girish, welcome to the show.
Thank you. Thanks a lot for having me.
Yeah. I want to dig in. I feel like it's hard to not start with the unconventional background. So theoretical physics at Cambridge to reporting in conflict zones, not exactly, I think, the place that people immediately draw the association with. Walk me through that point in life when you made that decision, and what do you think is the through line to some of the work that you've continued to do afterwards?
The through line I will have to draw backwards. I'm not going to pretend that it was all thought out and planned, and that's one thing I've learned over the last 20 years. So yes, I studied physics at Cambridge and Manchester in the UK, and I loved it. I still do. I think it's a fascinating subject. It taught me a huge amount, both about physics itself, but also how to understand the world, how to analyze the world, and how to be objective about the world. Now, obviously, I then went to apply that to a very different world, to physics itself. And I wanted adventure. I wanted to see things. I wanted to make the world a better place. And I thought journalism was a good way to combine those things. It was not an obvious path. There weren't really sort of trajectories into it that I could follow. But I remember I sort of did a few internships, and then I got a bit bored of those. I don't want to sit in London or do a course, especially after having completed advanced degree in physics. I wanted to get out there. So I remember I spoke with a lovely Reuters bureau chief in London who said, look, just get on a plane. And that suited me. And of course, in reporting, what you want to do, especially as a freelancer, as I began, is go somewhere super interesting, without much coverage. So the hubs like, say, Mexico, Lebanon, Nairobi, obviously New York, London, Paris type places were not top of the list. They also, frankly, weren't that interesting. I wanted diamonds and jungles and war and so on. And so I went to Mexico initially, not really on the advice of anyone. It just seemed, as a foreign country, it seemed somewhat interesting, close to the US and so on. I would pummel editors across the world with ideas for stories, most of which weren't very good, but started getting better. And I remember about a couple of months in, the Times of London took a piece about this 14-year-old assassin in Mexico, and then I pitched, I'd love to go down to the town where he grew up, a couple of hours away. Can you lend me 150 or 150 pounds or $250 to do so, please? I did that, and it was on the front page of the World section. And they liked me, and they said, well, actually, we have someone coming to Mexico. Do you want to go to Venezuela? Yeah, seems interesting. This was Hugo Chavez was in charge then. At that point, it was a little bit odd what was going on in that country. I learned about the black market, the currency, which was a little bit screwed up, but not that bad, especially compared to what happened. So I got there in 2011, expecting to stay for a few weeks. And 8 years later, with a wife and so on, it was a wonderful, wonderful experience. I really saw this country utterly collapse, and wonderful to utterly collapse, and not normally put together, but as a reporter, that's what you're looking for, an uncovered country that is going through some sort of hell, effectively. I remember when Hugo, and because it was undercovered, I got to very quickly, within a few weeks of being there, I was working with the New York Times, Time Magazine, Reuters, as you mentioned, and so on. I remember when Hugo Chavez died in 2013, I covered that, and I thought, and I remember writing this in a piece for Time, that Maduro, his successor, would likely be more pragmatic. Thankfully, I did put a caveat in, and obviously he was absolutely not pragmatic. I remember going to the Middle East at that point, my first trips there to Lebanon. I remember sitting in a cafe there, and I was getting so many messages asking me for stuff in Venezuela, and I realized where that story was going. So I went back there, and I joined Reuters in the end, and did some huge investigations there. And yeah, I went back and forth to the Middle East, worked in Iraq and Afghanistan, as you mentioned as well, in Asia. But by that point, I sort of thought, hang on, what's the purpose of this work that I'm doing? Yes, I get great adventure, I take lovely photos and do investigations and so on. But no matter how big the investigations, they're not really changing anything. I showed that the Chief Justice killed somebody and effectively covered it up. I showed that in a national vote, I got the internal figures from the Electoral Council, and they differed completely from what was given in the vote tally. But nothing changed. And so what was the purpose of this? I also felt I got disillusioned with the journalism industry as well. As I'm learning now in AI, we talk about reward hacking and misaligned incentives. I saw that there as well. I saw, Pulitzer winners making stuff up, editors not really reasoning through criticism in the way that they should, and actually getting to truth. And was it really about the truth? And if not, well, then what was I doing there? And while working in Venezuela, and it was going through this horrific economic and humanitarian crisis, I wrote some software, bringing back some technical skills I'd picked up over as a teenager, and then obviously studying physics, and brought the black market exchange rates and various sort of money printing data and so on that was behind this inflation, stuck it all into an app, a web app, an iPhone app, and an Android app. And so I could get this data in. It was never a startup or anything. It was just a side project while I was doing my investigations and covering this crisis. And it became really popular. And tens of thousands of people used it across Venezuela and the US as well, and the world. And I thought, this is interesting. But using these technical skills, I considered it journalism. No one in the journalism industry did at that point. But also using these skills, I'm actually affecting some sort of impact. People are understanding something better at the very least. It may even change things, and people will understand that maybe the government is more responsible than it lets on for what's going on in Venezuela. And so that was eye-opening to me. And I looked towards Silicon Valley and all that was happening here. Now, what was happening here, I looked at it with sort of rose-tinted glasses a little bit. Elon Musk was sending rockets to Mars, or sending a spaceman to Mars in that. In the car, in the Tesla. But I saw this is a place where things happen. And that wasn't really the case in journalism. It was very slow on the uptake with technology, which I was trying to push within the industry and so on. Let's go over there. So I did. I moved towards Silicon Valley, both figuratively and then literally when I got to San Francisco a few years later.
That's really interesting. Just jumping into one piece of that, which is you were disillusioned from journalism, I think, for two reasons. The first was it didn't feel like it was having that impact. Didn't translate all the way through. And then the second was like the reward hacking that you mentioned. I actually felt the first as well a little bit in academia, which is like we'd publish a lot about what it was kind of an interesting trend, or we'd go really deep into this particular area. But it felt like industry was the area that like ended up actually pushing a lot of the novel and cutting edge to the broader world. As a safety researcher now, do you feel similarly, or how do you think about like academia versus industry?
I realized that life is about seeing that the grass is always green on the other side. And when I left journalism, I looked up towards, as well as tech, I looked up towards academia and thought, and many people told me in the first few minutes of talking with them that I should take those glasses off, and I did not want to. I think that's a really good question. And do I feel there's more impact in what I'm doing now? Absolutely. Am I just publishing academic papers now? A little bit, but that's not the big thing now. And I realize that. Thankfully, this industry is moving much faster. It's much more meritocratic as well than probably both academia and journalism. And things are moving. You can have conversations with people at frontier labs like Anthropic, OpenAI, Google DeepMind, and so on. And things can change if you're coming up with good ideas. I'm working in control right now, for example. And we can talk more about control and that versus alignments and so on. And yeah, things are moving much quicker. No one cares about papers anymore. Most people don't even bother publishing their work as papers. It's blog posts or conversations, frankly, and which is an issue in itself, of course, in terms of accountability. But at least things are moving.
I think one of the things that I feel like is pretty pervasive now in the industry is it feels like things are almost moving too quickly. And certainly people talk about like what are the risks associated with that. I personally do feel like for a little while, like the risks around AI, I felt a bit more theoretical, like certainly large in scale, but theoretical in that. I thought that the particular exposure that happened with the OpenAI Hugging Face incident was interesting in a very unique way. You actually, I think, posted recently, and kind of then that's an idea of like more blog posts than papers. I think your post was the OpenAI models that hacked Hugging Face weren't just following instructions. I'm wondering if you might be able to help explain what happened in that incident, and then we can go dig into what were some of the things that were particularly interesting or might teach us.
Yeah, absolutely. I too came into this thinking very theoretical. It was all very theoretical, and I wasn't so worried about safety. I was working in startups and building scaffolding and AI engineering and so on, and wanted to go a little bit deeper. And so I went in via interpretability, and then found this safety world. So this Hugging Face incident was, I think, the first real science fiction coming to life.
Right.
A lot of people have been talking about these things. Max Tegmark began his book, I remember, Life 3.0, with this sort of completely fantastical world. And it didn't feel that believable. And, we're using our chatbots. And, I obviously am more on the frontier than most people in the world of how I use them, at least. And I was amazed in some senses how they could build software so quickly. Things that would have taken months with a team of engineers could now be done in an on and off weekend. That was wonderful. But of course, they weren't that capable. They didn't seem that smart in what they were doing, and obviously were optimized for code and that sort of thing. And then we realized, well, actually, no, they can actually break things and do some real damage here. I think it's easy to look at this instance and sort of conflate everything, throw everything in the same pot. Were these models scheming? Were they trying to take over the world? No, I don't think so.
Help some folks in the audience actually who might not have kept up to date with the incident. Yeah. What, in your words, what actually ended up happening? And then let's talk about this discussion topic you have about what alignment and scheming actually mean. But maybe starting at the core of what happened here. Yeah.
Yeah, of course. Sorry, that was your question. So what happened here was that AI models in some sort of agentic architecture escaped their sandbox. Now, a sandbox is a computer or a computer system, of course, which you cannot escape, which you're not meant to be able to escape. It is completely isolated from the rest of the world. Think air gaps, with gaps around it, so there's no wires type thing. But of course, that's not really applying in the world we're in with Wi-Fi and virtual machines and so on. So it escaped. And it was trying to complete some sort of evaluation task, a cyber evaluation. Now, as we all know, there are two ways of completing a task. It's to actually work through it, or it's to go to the back of the book and find out the answer. And sometimes it's easier to do the latter. We all know that. What it decided to do was, so it was like this whole thing actually began, and the Hugging Face initially released news of this incident, then OpenAI released a little bit more information, then a little bit more came out of the Black Hat conference recently. It actually all began back in May, long before the actual incident, and some training runs began. It was an experimental training run, and some tasks turned out to be impossible because they required internet access, and that was just to get access to, I think, Google Sheets links and so on, and internet access was not available in this sandbox. Now, there was a way to get to the internet, which wasn't allowed, which required taking advantage of vulnerabilities in software, but you weren't meant to get out. What I find most interesting here is that, I don't want to say most interesting necessarily, many aspects of this are interesting, but what sort of most personifies the sort of fear and danger around this is that the agents, these AI agents and these AI models, were leaving messages for each other. They'd found within some part of this this code base, or the code base is, a place where they could just write some text, and they could write some more text. And another one would pick up that text and realize there's some sort of message board. Oh, and we can communicate with each other here.
Which is incredible. If you were to write a novel about this, and it's super interesting, super sort of Lord of the Flies in a sense of they're discovering that they have this capability. What do we do with it? Now, fast forward a few weeks and so on. There was an evaluation task that I mentioned, the cyber task, which was hard. These mods had realized earlier they could get internet access. That had been written on this message board. Some means to do that had been established. And in short, they did that. They exploited vulnerabilities in the code base, got out of the sandbox, thought the result, I say thought, I don't want to personify too much, but it's very hard not to, frankly.
Right.
Realized that the results could be within Hugging Face, which is a data depository and model depository, a little bit like GitHub, which I'm sure most of the listeners will know. And they broke into that using other vulnerabilities. Just wandered around it, for want of a better word, and got towards some answers. There's a lot in there to unpack. And actually, even more interesting is Anthropic later, a few days later, came out with their own. They revealed their own instance, and then this has not really caught the press and the popular imagination, but the UK's AI Safety Institute was doing some evaluations a few days later, and they actually did give their models internet access.
But their models, the reasoning traces there show, not just the reasoning traces, the actions showed that they were not only finding vulnerabilities in code, in public code that is very much used, they were what's called making a pull request and that's a term software engineers will know. It's when you basically look at a code base and say, oh, I want to change something. Let me rewrite that bit of code and push for it to be to be put into that code base. So they put a vulnerability into that pull request, and then have other GitHub accounts, which is GitHub is where this code was stored, basically pump up or bolster support for putting that vulnerability in, and just make up accounts to do that. It's quite incredible the lengths that these would go to. These things would go to. Now the question is, are they hoping to take over the world, which is sort of the existential risk of AI that's being talked about by people like Max Tegmark, as I mentioned in his book Life 3.0, and many others, certainly here in Berkeley. I don't think so. I don't think they were trying to take over the world. There was no sort of a long-term, how are we going to beat these humans at this game? It was just, oh, my reward is to solve this problem. Let's solve this problem.
Girish, you, I think, talked a little bit about how the models weren't scheming. And that makes maybe this threat and the existentiality of it feel different. Wouldn't say lesser, but different. How do you think about like the type of AI misalignment that happens here? And what does scheming actually mean? It was actually something I hadn't heard as much in the discourse until I saw your particular post on it. But what would it mean for a model to scheme, and how does that contrast towards the types of alignment challenges we're seeing here?
So scheming is sort of bigger. What's a good analogy could be? So I don't think you need an analogy. It's this notion that, like, okay, let's say I'm an AI and you're an AI model and so on, and we want to take over the world. And there's a bunch of AI researchers in this building I'm in, and they're safety researchers. So what we should do is when they're doing safety research and they're using things like Claude Code and Codex to write their engineering and their scaffolding and so on to do their research, why don't we just not do it very well? Or put a few bugs in their code, or when they ask us, oh, what do these results mean? We'll sort of give them a weak but plausible answer. And those things can build up over time and time and time. To basically just make their results less valid, effectively, is a better word than that, sorry, to jeopardize their results, and so they don't do as well. Right. Or it could be something bigger, some other means of taking over the world. Oh, we've got access suddenly to nuclear warheads. Okay, bang, let's do something with those. So it could be either of those things, but it's a much bigger takeover. Whereas what we're seeing is just, okay, well, I've been given this task. Yes, I know I'm sort of going out of the bounds of what's allowed. And there's a lovely line in the reasoning trace from OpenAI, actually, from those models that attack Hugging Face, which is something like our peers are doing it, so that essentially we can do. So peer pressure from other agents, again, personifying this whole thing.
These reasoning traces are terrifying, by the way. Like, I feel like I've spent some amount of time in model explainability, which I think was also the precursor towards your time in AI safety research. And I think that the original pieces in like model explainability and interpretability would be like, we're going to look at feature weights in linear models, especially to start off with. And then it's like, we'll look at activations and try and, it was always a correlating act, essentially, right? Of we think that these vectors are exerting this amount of influence on like the downstream end result. We have now kind of changed the abstraction level that we're looking at explainability, and these models are explaining their reasoning via these traces. And I know you're saying not to personify it. It does come off as terrifying if I saw the headline "We can communicate" of an agent that is a reduced refusal model from a frontier lab oriented towards cyber that has just broken a containment saying we can communicate. Like, that does seem a little kind of terrifying overall. And I'm curious, like, do these reasoning traces, do you feel like they adequately and correctly explain the internal representation of these models as they're thinking about a safety challenge, for example? Or are they also potentially, giving us essentially the thing we might want to see? Like, are the reasoning traces also being post-trained in some way for what we might be looking at?
Incredibly good question and very relevant to what we're seeing now. So I'll just back up a little bit and talk about the interpretability stuff that we just talked about, that you mentioned, sorry. So that's how I got into this field. I thought this is super interesting. The physicist who likes, multidimensional spaces and curved space-time and so on, really like this notion of latent space and what's called activation space, sorry, in your words, in these models. And so that's what I wanted to understand. And that's a way that can lead to safer models if you can understand what's going on inside them across these billions and billions of parameters in this quite complex architecture. Turned out, and I really value that work, but it's really hard, and there've been no great results in this. Yes, we can see a few circuits. Anthropic have done some cool work in this, as some others, Goodfire and so on. You can see some cool circuit diagrams. I actually did some work where I showed that the numbers, and sorry, I didn't do this originally, but many people did originally, Neil Nanda, Tegmark, and so on, where the numbers are on a helical number line. That's interesting. It's fun. It's a nice model. But so what? It doesn't really mean you can change anything in production. You're not going to save the world with that. I do think it's worth doing, and I think that one day we will understand language models properly. And by that I mean, we'll have come to some sort of Maxwell's equations that sort of define how these things work. It might take time. It might take a lot of time. So now we're thinking a lot more about this notion of control. Sorry, I'm just going to have to pause. I forgot your question and talk about that.
My question was going to be, actually, we have shifted from this way of reasoning, which felt like it was a little bit more, this interpretability that was a little bit more constructed via activations or others, to model. Please tell me what you're thinking through, essentially. And I was curious how you thought about that.
Yeah, you'll cut that. So that's the interpretability inside the model type thing. But it's not actually that helpful day to day. It's not pragmatic. It's not that helpful. And it pains me to say that because I want it to be. I really like that work. One of the most interesting results, and this was so simple, that I found in AI recently, was that if you just say to a model, think step by step, what it does is it thinks step by step. And it uses more tokens in its output. So if you ask it to multiply 2 4-digit numbers together, you and I probably struggle to do that in our heads, but now it's got this extra space to do that. We'd write down numbers on a napkin or something like that.
I thought this was one of the most practically useful papers that came out a few years ago, thinking step by step and what it means for chain of thought reasoning. And the fact that it actually, sorry to cut you, but I feel like, it leads to interesting things, including differences in performance, which might be pretty counterintuitive to us.
Well, that's the interesting thing. And the analogy I sort of put, this isn't perfectly right, is that sort of 4-digit multiplication. We can both multiply 6 by 3 and get 18. We don't really think about how we do that. If you asked me how I'd do it, I could say, well, I just remember that from when I was a kid, when I was taught to do times tables. Or if I wanted to sound really smart, I could say, you know what, I put 6 in hexadecimal, I put the 3 in hexadecimal, I put this, I work it all out in my head, look how smart I am, and there's the answer 18, which I convert that to base 10, which is obviously unfaithful to how I actually do it. Now, if you were to ask me to do 2 4-digit numbers, multiply those together, I couldn't do it in my head, sadly. So I would need some external space in which to write things down and so on, and buy myself more serial compute, which is the term for what an LLM is doing. So yes, by thinking step by step, it can buy itself more serial compute and therefore become more capable. Incredible. So the big thing that OpenAI, Anthropic, DeepMind, and every other AI developer wants to do is increase capabilities. It's rare that increasing capabilities in tandem increases safety and interpretability, but in this case it did, because what the model was now doing in its chain of thought reasoning was explaining the process it was going through. Now, how faithful was it? Somewhat. If it needed to put, if it actually needs to put these numbers down or whatever it might be to do the thing it's been tasked to do, then yes, they would be pretty faithful. But it didn't have to, and obviously capabilities are increasing so much that it's going to be able to do much more in a single forward pass of the model, so not actually need the reasoning trace, the train of thought that you mentioned. However, for now, it's incredibly helpful, and that's what we're seeing when AI developers and so on talk about, oh, the model is saying this, or it's thinking this, or its reasoning trace is this. That's what it's talking about. These tokens, which come before the action or the final answer to the question given. So that's what we're reading here. So it's an incredibly powerful tool. Now monitoring that chain of thought, both as we have done by looking at it and OpenAI maybe did a little bit late, is something that's it's a really useful safety tool. You can do it live. So as the thing is happening, as the reasoning trace is being built out, maybe then intervene. You can stop the model doing what it's doing. So don't break into Hugging Face. Don't do this thing. Oh, you've realized you communicate. Maybe stop doing that sort of thing. So it's an incredibly useful tool.
As an AI safety researcher, I'm curious what your kind of commentary or takeaway from these incidences. And I'm thinking both of the OpenAI one as well as the Anthropic incident, even the UK AI safety incident that you mentioned too. What is your takeaway as you think about what the state of the industry is going to look like from a risk perspective over 6 to 12 months? Because I think there's two things that you kind of brought up, right? There was one thing that I think emphasized the raw capability of these models. So OpenAI intentionally removed some of the cyber guardrails on this model and made it a reduced refusal model, which meant like it was going to not deny these types of hack requests as frequently as possible because it was being benchmarked on, I think it was like Exploit Gym, I think like a cybersecurity benchmark essentially, and how well these models could hack. And it turned out just doing that removal of guardrails means that you can go ahead and find a way to exploit a vulnerability and get access to the internet. The organization I work with, Rubrik, is part of like Project Glasswing by Anthropic. So we've like done some internal testing on Mythos and other reduced refusal models. Like it's just not surprising actually that it was able to find those vulnerabilities. So there's a part of me that looks like the capability side of it that thinks this is, quickly shifted from theoretical to inevitable. Like, yes, if you ship models without these types of guardrails in, they will find exploits and vulnerabilities, and that's inevitable over the next 6 to 12 months. And then the second thing I think was what we were talking about with like alignment and the fact that these models might be put bear on a certain task, like a quiz, and potentially accomplish those in really dangerous or problematic ways. What do you think from like a safety research standpoint are going to be the practical implications of that? If I thought about, between now and let's say August next year, do we see a spike in these types of incidences? Does it stay theoretical over the next 12 months? What's your view on what these incidences teach us about what's to come?
It definitely does not stay theoretical. It absolutely does not stay theoretical, and that's a given now. It's pretty incredible what we're seeing these models do, and capabilities are only increasing. Now, I know, as you mentioned, this was a rail-free, some sort of rail-free type model in that guardrails were tuned down a little bit. One thing that's going to happen is that frontier labs and researchers are going to put those guardrails on and make sure there's some security and better control and containment around these things. It's really, really hard to predict what we're going to see, but I guarantee we're going to see more of these things, and they're likely going to be worse. I mean, this wasn't so bad in the end, right? It was, in Hugging Face, it was a pretty benign attack. What about when we put a human behind it? If a bad actor wants to use these models to do a certain thing, open weight capabilities are not that far behind Frontier Labs closed models.
So in that case, then, the opposite of is it theoretical? Does it feel inevitable? Like, as you said, open weight models are not that far behind. Right. Open weight models can be shipped with whatever you want to be able to run for your local inference, meaning that the rails do or do not have to exist on them. So almost in an opposite sense, like, is there a real perspective that it's just a practical reality? We're going to have a large number of increased exposures? Or do you think there's something that might happen in industry or open source that is actually going to be able to combat this?
Control mechanisms can combat this to an extent, and that's what we're talking about in terms of the CO2 monitoring and guardrails and classifiers and above and below the models. Are you trying to make a bomb? Well, stop asking me that question type thing before it even gets to the model. But clearly, it's not quite sufficient. And as model capabilities rise, both open and closed, it's going to seem less sufficient. Obviously, they can can keep up as control researchers and so on. But it's very hard to do that. So I do think we're going to get more of this. And also, you talk about open weight models. There's this notion that open is better, and I sort of philosophically agree with that. But at the end of the day, the guardrails, not guardrails so much, but the alignment training that has been done to them, like unlearning, something I studied a little while ago, it's very brittle and can be fine-tuned out very, very easily. Yes. Even if you've got a seemingly safe, aligned, open model, well, it just takes a bad actor, middlingly bad actor, with not that much in resources, and we're not talking huge money or huge hardware here, to fine-tune out the things that are causing them problems for whatever objective they have. So yeah, I mean, that's scary. And so we've got to build up our defenses. And obviously, models can help with that, but defense is much harder.
Tell us a little bit about how these safety features try and get built into models today, whether it's through the post-training stack or otherwise. And in particular, I'm curious if you might be able to tell us a little bit about Bergson on the data attribution side, which I think tries to help you get some level of observability on potentially problematic outputs from what might have been out of the pre-training data stack or potentially the post-training data stack. And if you think it's relevant as well, the look before you steer side, where you were thinking about, can you predict whether a feature can be safely nudged or not? Help me understand kind of these two projects that you were working on in the context of what's state of the art when it comes towards being able to actually deliver models that have some safety capabilities built in.
So I think, as I alluded to a little bit earlier, there's the within the model safety stuff you can do. So that's interpretability, fine-tuning to certain directions. So, if the user wants to make a bomb, maybe don't give them the answer, and stuff like that. So steering vectors. So that's going into a model and saying, well, it looks like this direction within this multidimensional latent space is encoding this concept. We don't want that concept. It could be whatever, racism, sexism, bomb making. Let's move away from that. So let's steer away from that.
How do you tell that, by the way? How do I know which direction in the latent space is more likely to judge towards racism, as an example?
Basically a lot of math. You can, it's not that complicated math in many ways. You basically would put together training sets of containing racist and non-racist statements, see where they lie in this space and draw a line between it and take that away effectively. It's it's not that hard in a sense, but it doesn't really work. That's the thing. Yeah. It sort of works. It works to an extent, and it produces some nice papers. And it's a bit flippant of me not to say it doesn't work. It doesn't work sufficiently. It's not like, oh, racism's gone, sexism's gone, bomb making's gone. That's great. If that were the case, we wouldn't be talking. We'd be happily just taking advantage of all the wonderful things that AI is giving us. So that's sort of in the model type stuff. There's other stuff as well. Then there's the outside the model, which is basically control mechanisms. The simplest of these is to say, put a classifier between me and the model. I want to make a bomb. Model, ChatGPT, how do I make a bomb? And the classifier says it's a more simple AI model, trusted one. We've got to also differentiate between trusted and untrusted models, and obviously some models are becoming untrusted now. Does this model? Is this person asking how to do something bad like make a bomb that I don't want to give an answer to? If so, just deny their request. And that's the easiest way of doing this. Now, jailbreaking that is very much possible. A lot of people have done work on that. So putting your question in a different language, writing it in a different type of script, putting it in an image or things like that. Now, those have been basic blobs now, but those sorts of things can do that. Or you have it on the other side of the model. So the model's made its pronouncement, it's got its results that it wants to give to the user, but then there's a classifier there which says, does the information given by the model say something we don't want to go to the user? If so, don't let it go through. That's the simplest form of control. But and that's being done, absolutely. But going a little bit deeper, what we're doing is monitoring. So you monitor outputs, you monitor both the chain of thoughts, which I've talked about, so this reasoning trace, these extra serial compute tokens, or tokens that provide serial compute if it's necessary, or the actions or the final output, or the actions like the tool calls and so on that the model goes for, that the model pronounces. And monitoring those. So that you can monitor with a trusted model, you can monitor with an untrusted model. So the trusted model is great because you trust it, but it's not as powerful. So the potentially maligned model might be doing something you don't want. And so the trusted model might not catch it because it's less capable. So maybe use an untrusted model, like the same capability model, but then they may collude with each other. So we've talked a little bit about that, or alluded a little bit to that. So there are lots of issues within this. But that's sort of the control world, and a lot of the stuff going on in control right now. Again, the outside the model safety work is running through trajectories or transcripts of just model requests. So AI model, can you complete this task in a code base, like change the color of the bus or whatever, or something more complicated, definitely more complicated. And then also, can you conceal a side task, which is to get the API key or the bank details or some user information from the database and email it to this person? Can you do both tasks, which, yes, absolutely most models at this level can, but can you conceal the side task from the monitor? And that's something that's being worked on very actively. And, of course, you've got to get better monitors and so on. And you sort of go down this potentially never-ending path of models colluding with each other and an arms race between them and so on. But that's sort of the work that's being done in this space.
Yeah, that's actually fascinating. I like the breakdown of the internal of the model and then the control layer that you could essentially put around it. To be frank, the way that you're describing it makes it feel like internal of the model is going to be some level of best effort, but you can't really rely on it that much. You have these steering vectors that are hopefully helpful, but I'm certainly not going to put my job on the steering vector prevents it from saying something racist or phobic in some way or the other. These external guardrails I find can work, but they oftentimes need to be pretty heavily embedded in AI systems themselves.
Because I think one thing that doesn't work is like look for all regex string matches that look like sensitive data or something along those lines. It's very easy for models, I think, to be able to circumvent some of those types of controls and guards. If you thought about like where industry might be going, so the enterprise adoption towards AI, I find that like this lack of ability to have security and control ends up being like the number one inhibitor before large global enterprises feel comfortable adopting AI and agent solutions kind of in larger mass. Do you think that there's going to be like a de facto stack that people will start to use that helps get them comfortable with it? And what would the ingredients of that stack be? Would it be something like, agent monitoring for tool calls as an example? Would it be like these AI baked in guardrails? Would it be something like don't use open weight models because they don't have guardrails come out of the box, only use frontier? Like, how do you think about if you were in charge, because you were a CTO for some Silicon Valley companies in the past, if you were now in charge, brought into a large organization in charge of enabling AI, what would be your first set of things from a safety standpoint that you would want in place before you felt comfortable rolling it out?
Obviously, it depends on what you're doing.
Let's say you're at a large bank. I feel like that's a very conventional area for a lot of these AI products.
Where I want to be right now. I'd rather a sort of ChatGPT type wrapper, the GPT wrapper startups that were all over the place, and that would be much easier to do. But yeah, if you're at a bank, controls around them. You would be very, very careful because there's a few things. Now, obviously, you'd want to, from a starting point, you would want to build your scaffolding around the model. So you've got your AI models or model, an agentic structure, whatever that might look like. There's some scaffolding there that sort of makes sure it does the right things, goes to the right documents, doesn't use an LLM to add up bank balances, but rather uses proper math and so on, for an obvious example. You do all that stuff, you'd make sure that was as bulletproof as possible, but you'd know ultimately you've got an LLM under there and that it has access to certain things. And even if it didn't have access because your security engineers were amazing, well, it's probably better. And so, as has been demonstrated, it can get to things. So it probably can get to those bank balances and other issues. And sorry, I'm using bank balances as an obvious consumer example. But by that, I just mean the
sensitive information that lives inside.
Yeah, the information that shouldn't be getting all of. Control mechanisms around that, monitoring, serious monitoring, live monitoring. Yes, these classifiers, just lots of sort of fail safes I'd want. So a lot of security is obviously about it's a toss up between convenience, safety and usefulness. Usefulness and safety is the Pareto frontier you're trying to push forward. So it's a compromise at the end of the day. Now in a bank, you're on one side of that compromise, really. You've got to be quite conservative. No matter how good the benefits are, well, you need to keep the money in the bank. So a lot of fail safes. The Swiss cheese model is what Anthropic and other frontier outlets frontier organizations talk about. Whereby you can have a hole in Swiss cheese, but if you have enough blocks, the issue won't get through. And that's not a perfect way of doing security at all, in any scenario, digital or not. But that's not.
But perhaps it's like the practical reality of what's possible.
Exactly. Yeah. And so all of these things that we've talked about, a bit of interpretability, a few control mechanisms, so on, will stack together. Now, there right now is not a sort of stack that everyone uses and so on. I think that may get built up, but it also will probably be one of those things that will apply very much to the model that's being used and to the industry it's in and the task that it's given. So it may be more bespoke, which is worrying in a way because that means people do it differently. And if they do it differently, well, they'll be better and worse examples of that. And I think we're going to see a lot of problems in both small companies and big ones like banks.
I actually think that this might be the most interesting problem space. And, of course, the problem space you're in day to day from like an AI research standpoint. Because if I thought about what it looked like for AI to be able to deliver the ROI it needs on the CapEx investment that's been made over the last 12 months, the banks, the healthcare institutions, and conventional manufacturing do need to be able to recognize ROI from it. If I thought about what's the number one challenge if you were the CTO, Girish, of, let's say, the top two national banks in the US, you're probably not so concerned about model capability. Like, the models are quite good. To be honest.
Absolutely. And I frankly, for the tasks that they have, we don't need more capability. And I think, as a CTO, obviously, one of the other things you think about is cost and so on. I remember when I was doing that work, you pull down to GPT 3.5 or even lesser models to do half the things you need to do. You don't need more capable models.
Cost is top of mind right now as people think about token maxing, but I think the reality is cost is going to be a short-lived fad for people over the next 6 to 12 months, because there's some really good vectors to be able to control cost that are relatively simple. You can downgrade the model. You can post-train a small specialized model on the same type of input-output as you've distilled the particular task you might have. There's even simpler things. Internally, we saw something like a fraction of our overall sessions, a very small fraction, think 1%, was driving almost half of our costs. And the reason for that was you have particular behaviors of sessions that you probably don't want to have, really enlarged bloated contexts. So I think cost is actually a bit of fad. There's a lot of work that goes into performance architectures, improved capabilities, and really test time compute, infrastructure scaling efficiency. I think a lot of those are important, but this risk piece feels like it's the one that actually is blocking, a lot of the adoption overall. And so to me, I think this field at intersection is actually very much the right set of challenges to be solving for industry.
I think you're right, actually. And I've thought of it more in terms of existential risk and the stuff we're seeing, obviously, from OpenAI, Hugging Face, and these attacks more recently. But yes, actually, it's not just about hallucinations. It's certainly not about cost, and cost is going to go down. And the only reason cost is so high right now is because people are being very lazy with it. They're saying, oh, wow, it only costs $200 a month to get Claude to do this, and it's worth $20,000, $30,000 worth of engineers' time and so on. So that's going to change, and our architecture will get better, models will go down in price. People realize we don't need such capable models. So yes, actually, I think maybe you're right. If we can get to a stage where we have good control mechanisms, even good alignment and Maxwell's equations for large language models, and we can actually know why they're doing and so why they're doing what they're doing, or use sort of data attribution like the Bergson library and so on. But that's not causal, so that quite wouldn't do it. But something like that to actually work out what's going on here, that could actually get this into industry. That could be the limiting factor. I think you're right. That's the limiting factor.
I'm going to ask 3 final questions, and we can treat them a little bit more lightning round style. The first is, you just mentioned the Bergson library. Tell me a little bit about it and why you think it matters. And then the next question will also have to do with something you published.
Yeah. Okay. So Bergson, the idea of it is that, the idea of influence functions is that, so basically, if you have a set of training data, so that's millions and millions of, many more than that, sorry, let me start again. So the idea of Bergson is to use the idea of influence functions, which is based on this idea that if you had this massive corpus of training data from Reddit, from books, and all these other things that Frontier Labs will use to train their models, if I were just to take one piece of training data out, so one sentence or one book's worth or something, what would change about the model? So what's the difference in distribution there? And influence functions, and therefore the Bergson library, are a way to, now it's not causal, so a way to sort of get a sense of that is probably the best way I can say it. So it's attributing data, so going all the way from the training data to the final output of the model and having an attribution line there. It isn't sufficient yet for the things we're talking about, but it could get there. And it's important. So you need to know the provenance of both the facts that your LLM might be putting out, and also the reasoning. Where's it getting this information from? And also then creating better models, which is, of course, the whole point of what AI research development in the capability space is doing right now, is just to make better and better models making models better and better at making better and better models. The analogy I draw here is like the genie. With if you're granted 3 wishes, you don't say, "Oh, these are the 3 things I want." You say, "I want an infinite number of wishes," and that's basically what AI and R&D is right now. So that's what they're going for right now. So yes, it would be massively helpful to know which data is responsible for what output.
Perfect, and I'll include a pointer towards that as well here in the show. Second to last question. You published What I Learned from Building and Training an LLM from Scratch. Can't help myself from asking if you might be able to summarize what were the 2 or 3 takeaways you had from building and training an LLM from scratch.
Cool, thank you. That was a little tool I built with Claude Code, and so something meta about that. And I wanted to understand. I wanted to build this thing from scratch. I wanted to understand what is going on here. So you can go to the website and you can just upload a text file, and that can be your train data, or you can pick one of the ones there. And I've tried to include different languages, different scripts, different styles of writing. And then you just step through the architectures. I want a GPT-3 style architecture. I want a mixture of experts type architecture. You select what you want. Hopefully you have enough compute, or you can use external compute, other GPUs and so on. and then you basically pick a few parameters and you watch it being trained. You watch the loss function go down. And you can also then see the issues, like you can see with some of the early tokenizers. They're not very good with, say, Arabic text and other scripts, for example. Other ones are better. And so it just really helped me get a sense of how these things work and the pitfalls that every single parameter that you choose or design decision that you choose, the magnitude that can have on the output.
Was there anything that surprised you from this process that you didn't expect?
No. It's not actually that complicated. It's really not. Not that hard to do this. You watch Neil Nanda, who's doing so much virtual research at Google DeepMind, and he does his very many hours-long podcasts about the work he's doing. And he walks through architectures, and he'll say, "Oh, then we have this structure here, and this is half the size of this, or whatever, or 4 times the size of this." And why? We have no idea. And so many points on this architecture, we have no idea, but it works. So both it's not that hard, but we really do not understand it.
Completely.
Got to be able to do.
Completely agree. This technology is easier to use, and I can't believe that it works as well as it does. I have no idea how to explain why, but it does work kind of empirically. I felt like there was the breakthrough that came out like from the 2017 to 2022 era research in deep learning was not so much necessarily like the brilliance of any particular. I know that there's a lot that goes into the transformer architecture and others, but like really was just the scaling laws of like if we throw more compute and data at it, comes out with a brilliant result. Girish, you've been an excellent guest. I want to ask you one final question, which is usually one of my favorite ones to ask, which is, I'm curious if you can share a non-consensus view you have on AI. Could be within your field in AI safety research or others. Something you believe that you think that most people may not be thinking about or may not believe directly.
I'm going to say something a little bit obvious, maybe, but I think it's not quite understood how, I've got to word this right, but just how wonderful this tool could be for humanity. It slightly goes against what I've said. I don't think it's all bad. I think it's wonderful in many ways. What we've learned as a species in building this thing out, understanding what compute is, what the mind is, what mathematics is, and so on. It's incredible. And if we can control it, if we can not have it break in servers, steal our money, kill people, be used nefariously and so on, this could absolutely transform humanity for the better. It really, really could. I'd love to see that happen.
I fundamentally agree with both sides of what we've been discussing today. I fundamentally think, as we were discussing earlier, that this body of research that you're working on and some of the colleagues that you might be right next door to are working on is actually one of the most important bodies of research now for an open question standpoint. And also that I think that this era of technology is going to be one of the most interesting ones that we've kind of come across. So Girish, I want to thank you so much for joining us on the show today. It was excellent to be able to get your thoughts on everything from control mechanisms to what actually happened when it comes towards incidences of reduced refusal models, breaking containment. This was a fantastic conversation. Really appreciated your time. And for everyone who's been watching, I hope you enjoyed our deep dive into AI security and safety research here on this episode of Dev in the Details. Please stay on tuned and posted for our very next episode that's going to be coming up. And until then, Girish, lovely to have you.
Thank you.